Hi, this is a quick overview of my scanning and data manipulation process for prosthetic sockets, part of my industrial design major thesis. We're going to start off with placing the camera in front of calibration panels and launching the David laser scanner software. Once we pull up the image, clear black and white image, we can calibrate the camera. Next up, what we're going to do is just drop off the model into the scene, into the furthest corner, and what we're going to do is switch the laser line on, switch the light off, make sure we've got a clean sweeping line across the entire model, and we can start scanning. So what you see over here is a depth image of what the camera is capturing, and what we want is a really tight series of lines. So we've got that there, and we can check the model. We've got really smooth faces, one big hole, but we can clean that up later on, and we're going to save that face. So what we're going to do here is just rotate the model. We're going to do this 4 or 5 times and repeat the last few steps. Over here we're just opening up all the scans that we've got, and we're going to arrange them out evenly, and we're just going to delete all the noise that's come off the scan. So you can see all the little bits on the end over there that don't really look like they belong to the prosthetic socket. We're just going to very quickly hold shift down, highlight the areas, and knock them out. So what I'm going to do over here is I'm going to start matching the faces up. So very quickly, you just click on one and click on the other. As long as they correspond, you can match them up, and then you can start doing a really fine registration so they fit together in a much smoother pattern. As you can see, this is a really quick process. As long as you've got them all lined up in the same axis, you can have a 360-degree view of your model very quickly. So what we're going to do now is pull the model that we've exported out as an OBJ into SolidWorks, and because OBJ is not a very friendly format to be working with in a parametric modeling environment, what we're going to do is use the Scan to 3D tool and create a couple of profiles across sections of the OBJ, and this will give us a way of manipulating the data. So what I'm doing over here is basically adjusting the curve fit so we get a really tight fit without any problems. As you can see here, there are a couple, and what we're going to do is adjust them so that they're really tight. Once that works out, all we have to do is hit OK. And now we can hide the OBJ that we worked with, and we've got a set of profiles that we can start manipulating. So all I've done over here is just dropped in a guide curve right through the middle, and that's going to help with the lofting. So we just select all the open profiles, and that long curve down the middle is basically our guide curve, which tells it where to loft down. As you can see, this is the most time consuming part of it, because you've got to select every single one. Let's grab the last one there. Once that's done, we've basically got a shell to work with, which means that now we've got a way to modify the surface. So what we're going to do here is drop in a couple of constraint lines and add in a couple of manipulation points. And what we can do is accurately modify the topography of the socket to be able to either bear loads or alleviate pressure sensitive areas. So once that's done, basically on the side axis, what we can do is create a curve and create a quick cut across it, which will give us the exterior lips of the trans-tibial socket. And just very quickly after that, just highlight the internal edge, and we're going to give that a really quick small fillet so that there are no sharp edges in the printing, and it makes for a more comfortable fit, more comfortable interface with the amputee. And that's basically it. If you save that as an STL file, you're just about ready to start to print. If there are any additional questions or queries, please refer to my thesis document, which is available at www.ytid.wordpress.com.